Greetings everyone. I am Dr. Sandeep Markad, working as Assistant Professor at Toshnawar Arts, Commerce and Science College, Simla. I am presenting exploration of shoreline and associated changes using remote sensing techniques. Shoreline is the interface between land and water. It is a highly dynamic environment due to strong interaction between water with land features. Shoreline is continuously changing due to different natural phenomena such as storms, cyclones, floods, sea level rise. Moreover, many anthropogenic activities such as coastal structure construction, dredging, extraction of sand is continuously changing the coastline. Therefore, it is necessary to implement appropriate protective and management programs in order to conserve coastal areas and environment. For that, information regarding shoreline is necessary. There are several methods used for extraction of information regarding shoreline. These methods include actual ground surveys using GPS, use of coastal maps and charts, use of photographs, as well as satellite remote sensing data. Remote sensing is the art and science of obtaining information about an object, area, or phenomena through the analysis of data acquired by a device which is not in direct contact with the object, phenomena, or area under investigation. Remote sensing provides synoptic view with good temporal and spatial resolution on continuous basis. Remote sensing data can be analyzed using visual methods as well as digital methods. Remote sensing provides rapid and low-cost information collection as well as facilitates the study of sites which are inaccessible with conventional methods. Remote sensing mainly use electromagnetic radiations which are reflected from different Earth features. Electromagnetic radiations interact differently with different features, and these differences in the reflectance pattern of EMR by different features are used for extraction of information of different features. Interaction of electromagnetic radiations with water vary according to the wavelength of the radiation. In visible range, water reflects very less amount of EMR, while infrared and above radiations are completely absorbed by the water. For other land features, reflectance in infrared and higher radiation is very high. Therefore, infrared bands of satellite data are mostly used for mapping of water bodies as well as shoreline. There are different satellites such as Landsat satellites, CPMSS, TM, PTM, OLI and tree sensors. Indian remote sensing satellites having leaves, panchromatic and other sensors. There are satellites having ADSTRS and many other such satellite and sensor data is used for assessing shoreline changes. The main part of extraction of information from satellite data is image processing. Image processing is mainly divided into two parts. First is image pre-processing or rectification and image processing. Image pre-processing includes geometric correction to correct the geometric distortions in the satellite data arise due to variations in the sensor platform, earth curvature, atmospheric friction, non-linearity of swipe of sensors and other such phenomena. These errors are removed systematically or diskewing or by using ground control points. Radiometric errors in the satellite data which arise due to changes in the scene illumination, atmospheric condition, viewing geometry and instrument response characteristics. These radiometric errors are generally removed by converting digital number values of the satellite data to absolute radiance value or top of atmosphere reflectance values. Noise is also removed from the satellite data using systematic and non-systematic methods. Image processing for mapping of shoreline can be categorized into visual interpretation and digital image processing. Visual interpretation of topographic maps, photographs, as well as satellite image data can be done for mapping of shoreline. For that, on-screen as well as hard copies of these material is used for manually digitizing the shoreline image subtraction, wherein before image is subtracted from the after image, wherein a difference image is derived which shows erosion and deposition. Erosion is shown in red color, whereas deposition is shown in green color. The appropriate selection of threshold value is essential in image subtraction. In another method, the after image and before image band ratio is taken and it is used for mapping of shoreline and associated changes. Then unsupervised classification of satellite data is also used, wherein satellite data, image data is classified into different classes or clusters using RC data. In these classes or clusters are again recorded into land and water classes for mapping of shoreline and associated changes for respective years. Then contrast manipulation can also be used for mapping of shoreline. Histogram of such data shows two peaks, and the value between two peaks can be considered as threshold value for mapping of water and land. Then conversion of satellite data into principal component is also used for mapping of shoreline using classification, image subtraction, and other such techniques. The study showed that digital satellite data can be effectively used for mapping of shoreline as well as associated changes with better accuracy. This method is rapid, cost-effective, and accurate as compared to conventional methods. There are different techniques which can be used based on desired accuracy level, time, and cost. Visual interpretation technique is time-consuming, tedious as compared to sophisticated digital image processing methods. Band ratio and image subtraction use fast results with poor accuracy, whereas principal component analysis and image classification requires more time and provides results with higher accuracy. These techniques need to be evaluated with reliable reference data for accuracy assessment. Combination of these techniques may be used for more precision and accurate results. Thank you.